Let's discuss reflection at curved surfaces. Fundamentally, you talk about curved surfaces or plane surfaces, basics are same. With a plane surface, we used to say that there is an incident ray, then you draw a normal, and then we get a reflected ray. Angle of incident ray with the normal, if it's theta, then that of reflected ray from the normal is also what? Theta. This is something which we discussed in plane surfaces. For an object, we used to define that intersection of incident rays gives us what? An object. For an image, we used to have intersection of reflected rays. Front of the mirror is real, back side is what? Virtual. All those things are similarly valid when you talk about a curved surface. Suppose we have a concave mirror and light falls on this concave surface. Let's say like this. This is the incident ray. Then, although it's a curved surface, but if you look at the portion where this incident ray hits the curved surface, let's just consider this portion where light hits the curved surface. For this small portion of the curved surface, you can consider this part as a plane mirror, and therefore you just need to do what? Next, you will draw a normal at this point. If this angle is theta, you will say that reflected ray will also make same angle theta. It doesn't matter if it's a curved surface or a plane surface. Basics are same. Anything in front of the mirror is real. And if you form things behind the mirror, then they are virtual. That means the only thing is that spatial part which happens because of the curvature of the mirror, we are interested in that part. And more specifically, from 10th onwards, you know that we want to develop a formula like this. Mirror formula. F, focal length, V, distance of image, U, distance of object. With proper sign, we'll see these things. And these distances are taken from the pole of the mirror. What is pole and all these things? Look here. That's the mirror. This point is pole of the mirror. And then we'll later on see that you can consider any point pole of the mirror. But as of now, let's say the center point is what? Pole. This line is called principal axis of the mirror. This is principal axis of the mirror. If you place an object, let's say at this position, and let's say pole is P, then this OP distance is represented by U with proper sign. We'll see that. If image of this object forms at I, then this distance IP with proper sign is V, and when light rays they arrive parallel to the principal axis, then after reflection, the point where they meet, this point is called focus of the mirror. Its distance from the pole with proper sign is what? F. We will develop this relationship for a concave surface, but that relationship will be valid for any type of mirror. Even if you take a plane surface, you can take concave, you can take convex, or you can take plane surface. This relationship is valid for any type of mirror. There are some restrictions. These are called spherical mirrors. And when you have a spherical mirror, there is a problem, which you can understand from this figure. When these rays, they meet, they do not meet at a single point every time. Suppose you take a ray at this position, somewhere here. Then its intersection will take place somewhere here. That means what? You don't have a single focus. There are multiple focus. There are multiple points on the principal axis where these rays meet after reflection from the curved surface. Not for these rays only, for any ray. Suppose you have an object at this place, and that's your principal axis. Then a ray coming from this object, if it meets at this place, then another ray may meet at this point, giving you multiple points where image formation takes place. Because of this, we say that the mirror which we are using has a small aperture. Small aperture means instead of taking a large mirror, if you confine yourself to a small portion of the mirror, not so small that it becomes a plane surface, but small enough so that we can consider all these intersections take place at a single point, then we can use concept of spherical mirror using this formula. And then later on we'll see that what happens if you take rays which are far away from the principal axis, how to tackle these things. We'll see this part later in ray optics. But as of now, remember, all the mirrors, all the curved mirrors which you consider, they must have small aperture so that we get a unique image after reflection from the curved surface. In fact, you can mention this as an important point. When we consider spherical surfaces, aperture size should be taken small. Aperture size should be taken small so that all the rays after reflection meet at a single point. So, I hope this much part is clear, and now we'll start developing mirror formula, which is relationship between focal length, image distance, and object distance taken with proper sign. Just note down this much and then we'll start developing this formula. So, we have a concave spherical mirror. Although it looks large, but remember, aperture size is small. This is the principal axis. This point is pole represented by P. This is the position of a point object. This point object is placed on the principal axis at O. When a light ray coming from O falls on this mirror, the next thing you do is you draw a normal at this point. So that's a normal. This is the normal. And if angle of normal with this incident ray is theta, then the reflected ray which we get will also make same angle theta. And this is the reflected ray. This angle is also what? Theta. Now, for object and image, we say that intersection of incident rays. This is only one incident ray, you need to have a second one. And similarly, this is only one reflected ray, you need to have a second one also. That second incident ray is this. If you look at this incident ray, which is moving along the principal axis itself, then at this point, principal axis is the normal. If principal axis is the normal, then reflection will also take place along the same line. So this becomes your reflected ray. This is the incident ray. Intersection of incident rays, it is giving you what? An object. Intersection of reflected rays is giving you what? Image. This is your image point I. And then this is the normal and this is your spherical surface, and therefore this point where this normal, and remember principal axis is also what? A normal which you draw at pole. For a spherical mirror, two normals always meet at the center of curvature. This is the center of curvature. Our aim is to find relationship between OP, which is object distance, and IP with CP. First, we will establish relationship between these distances, and then we'll see how to relate this thing with focal length. Now, remember one thing, whenever I write things like these, OP, IP, CP, these all are distances. These distances, remember, are always positive. Remember this part. And then later, we will develop a sign convention, which we will see later. Now, how to find relationship between these distances? Look here. Say this angle is alpha, this angle is beta, and this angle which you see is gamma. Alpha, beta, and gamma. And let's say this point right here is M. If I drop a perpendicular from M onto the principal axis, if I drop a perpendicular, then the point where it meets, this perpendicular where it meets, let's call it P dash. But as I told you, this aperture size is very small. If it is very small, then we can say that P dash is approximately what? 0. What is happening? Look here. Instead of choosing a very large mirror, we are focusing on a small aperture of this mirror. Something like this. For a small aperture, from this point, if you drop a perpendicular, I don't know you can see it or not, but this distance is very, very small. That's what I have written here. What is the advantage of it? Once you draw a perpendicular, then you can develop these right angle triangles. You can develop these right angle triangles. You can develop these right angle triangles. And once you develop right angle triangles, you can always use tan alpha, tan beta, tan gamma as perpendicular upon base. That's the reason we drop a perpendicular onto this principal axis. But we have got one advantage now. Since PP dash is approximately 0, IP, which is distance of image from the pole, you can say is same as IP dash. This part is negligible. IP is approximately what? IP dash. Same goes with these things. This becomes OP dash and this becomes CP dash. Like this. Now you will understand it. Let's write down the values of tan alpha, tan beta, and tan gamma. Tan of alpha. What is tan alpha? Look at this triangle. Triangle MOP dash. In triangle MOP dash, tan alpha is MP dash upon OP dash. Tan alpha is MP dash upon OP dash. Tan beta is coming MP dash upon, this is beta. Tan beta is perpendicular upon base, which is CP dash. That's your CP dash part. That's your CP dash. And similarly, you can obtain tan of gamma, which is coming MP dash upon, tan gamma is MP dash upon IP dash. Now, let's take another approximation. Since aperture size is very small, all these angles which incident ray makes with this principal axis, normal makes with principal axis, or reflected ray makes with principal axis, these angles are also very small. These angles are small angles. And maths tells us that tan theta is approximately theta if theta is very, very small. We can use this approximation if Angle is what? Very small, which is like tan 0 is approximately what? 0. We can simply remove tan. That means this tan alpha can be approximated with alpha. This tan beta can be approximated with beta, and this tan gamma can be approximated with gamma. Now, look at this triangle. When you look at the triangle O, M, and C, alpha and theta, these are what? Internal angles. And beta is what? External angle. In triangle O, M, C. That gives you what? Alpha plus theta is what? Beta. Alpha plus theta is coming what? Beta. This information you got from triangle O, M, C. Alpha plus theta is what? Beta. Similarly, beta plus theta becomes what? Gamma in the triangle C, M, I. When you consider triangle C, M, I, C, M, I, beta and theta are the internal angles. Beta and theta, these are what? Internal angles, and their sum is equal to what? External angle gamma. This is external angle gamma. Now once you reach this stage, you should remember that we need to eliminate theta from these two equations. Why? Because we don't need theta. We need what? Relationship between these distances, and that will come with the help of alpha, beta and gamma. And therefore, let's get rid of this theta part. Now how do you get rid of this theta part? Simply subtract second equation from the first one and you get this. Alpha minus beta is coming beta minus gamma. Alpha minus beta is coming beta minus gamma, which is alpha plus gamma equals to 2 beta. Alpha and gamma and beta, we have related these things. Now, alpha, we have the value of alpha as what? MP dash upon OP dash. Let's put it here. Alpha is MP dash upon OP dash plus gamma is MP dash upon IP dash. Gamma is MP dash upon IP dash, which is 2 times beta, and your beta is MP dash upon CP dash. MP dash upon CP dash. From the numerators, you can always cancel MP dash, MP dash, MP dash, giving you what? 1 upon OP dash plus 1 upon IP dash, which is equal to 2 upon CP dash. This is the relationship which we are looking for in this article. Relationship between object distance from the pole, image distance from the pole, and distance of center of curvature from the pole. Next part is converting these distances into proper U, V and R. How do we do that? Look here. This pole is considered origin. Look at this place. If you have a mirror like this, it can be any mirror. concave, convex, always consider pole as origin. Now, once you say pole is origin, you know that on the left side things are negative, on the right side things are positive. And then later on we'll see that up is positive and down is what? Negative. When we are interested in height of the object and height of the image. As of now we are interested in distances along the principal axis. So origin left side negative, origin right side is what? Positive. When you say u, when you say v, or when you say r, u object, v image, r radius of curvature, u, v, r, they should be taken with proper sign. In fact, you can write down this as an important note. U, V, R should be taken with proper sign. U, V, R should be taken with proper sign. What do I mean by proper sign? In this setup, if this is origin, then things on the left side, they are what? Negative. In fact, everything in this setup is on the left side, and therefore OP dash, if it is 8 centimeter, suppose OP dash is 8, then U cannot be 8 because OP dash is distance should be positive, but U, V, R, the values should be taken with proper sign, and therefore you must write U as what? Minus of 8. That's the meaning of taking UVR with proper sign. For this setup, this 8 is nothing but OP dash, and therefore U becomes minus of OP dash. V similarly becomes minus of IP dash. If IP dash is 3 centimeters, then right here you will write 3. It's a distance. Remember this part. But V should be taken with proper sign. So this is 3 on the left side of the origin, and therefore V should be minus of 3, which is minus of IP dash. And lastly, the C, P dash, your R radius of curvature becomes minus of CP dash. Once you found these values, let's put these values back in this equation. OP dash, what is OP dash? Minus of U. This OP dash becomes minus of U. IP dash becomes minus of V. IP dash becomes minus of V. CP dash becomes minus of R. Now some people think that, so you are saying these are distances, then how come they are negative now? No, they are not negative. Look here. U itself is negative. Negative of negative becomes what? Positive. Similarly, V and R, they themselves are what? Negative. Negative of negative, that makes them what? Positive. Which gives us 1 upon V plus 1 upon U equals to 2 upon R. We are almost there. This format is also important. You can remember it like this. We have got what? Relationship between object, image and center of curvature, and that too with proper sign. If for this mirror or for convex mirror, let's say image forms on this side, then this formula will take care of all those transformations coming from left to right automatically, because while we were developing these things, we took care of proper sign convention. Now, if things take place on the left side, they will automatically come negative. If they are on the right side, they will automatically come positive. We'll see examples later on and you will understand this part better. Now, let's finish the whole thing. This 2 upon r. How can we handle this 2 upon r part with the concept of focus? Let's look into that. Do one thing, just note down this much first, and then I will discuss how can we convert it into the final format. Note down this much. Now, if we have a concave surface, concave spherical mirror, and rays are coming from infinity, then rays coming from infinity, they are basically what? Rays parallel to what? Principal axis. Rays parallel to what? Principal axis. If you say that these are incident rays which are parallel to principal axis, then intersection of incident rays gives you what? Object. But these rays are parallel and therefore the intersection will take place at infinity. If intersection of these rays takes place at infinity, that means object in this situation is at infinity, which means what? Which means u is minus of infinity. Distance wise infinite with sign minus of infinity. And then we know that when parallel rays meet after reflection, when parallel rays meet after reflection, they meet at the focus. They meet at the focus. This is P. Now, if I say FP, then remember it's what? Distance. You can always write FP dash, but it doesn't matter now. But in case you want to write it, FP is what? Distance, should be positive. But if you want to define focal length F, then you can see this focus point is on the left hand side of the origin, is on the left hand side of the origin, and therefore F must be negative. Negative of what? This FP. This F P, if is 5 centimeters, then FP is plus 5, but F is not plus 5, F is what? Minus of 5. So, this minus of FP, this minus of FP, FP is basically, if you wish, you can write FP dash so that things are symmetrical. So your F is coming minus of FP dash. Now, let's use this formula which we have developed so far. What's the meaning of U? Object, distance. We can see that with proper sign. What's the meaning of V? Image. What is image? Intersection of reflected rays. These two rays are basically reflected rays, and therefore their intersection should give us what? I. That means FP in this setup is nothing but IP. IP. And you know that you can always write it like this. Fp dash is what? Ip dash. Basically what I am saying is this Fp dash, is what? Minus of F. And what is Ip dash? Minus of V. That gives us V as F for this figure where rays are coming from infinity. Now let's put these values in this function. And when you put these values, you get what? 1 upon F. We replace it with what? F plus U, which is at minus infinity, 2 upon R, giving you 1 upon F is 2 upon R, or F becomes R by 2, which in itself is an important formula that gives you focal length of a spherical mirror in terms of its radius. The more important thing is, you can always write this 2 upon R, you can always replace this 2 upon R from now onwards in this form. 1 upon V plus 1 upon U is 2 upon R, which is 1 upon F. That's the relation which we are interested in. 1 upon F equals to 1 upon V plus 1 upon U. Now why do we write it as 1 upon F, not as 2 upon R? It's just to define the concept of focus. If you do not wish to, there is no restriction. You can always go for this. Just take care of all these things with proper sign. But since we have reduced this 2 upon R into 1 upon F, mostly you see this version only. 1 upon F equals to 1 upon V plus 1 upon U. You need to remember what? This formula is valid for any type of mirror, and whenever you take care of these things, don't forget proper sign convention. F, U, V, R, everything should be taken with proper sign. Put on this and then we'll see an example so that we can understand all these things in a better way. Now look at these examples. Suppose they have given us a concave mirror and question says that radius of the mirror is 20 centimeter. The question says radius is 20 centimeter. They have given us the numerical value. But you know that for a concave mirror, this is pole, which is origin, center of curvature lies on the left side, and therefore radius is minus of 20 with proper sign. Question says radius is 20, but you know that it is on the left hand side, and therefore R becomes what? Minus of 20. And we have an object and distance of object from the pole is given as 50 centimeters. This is 50. Then U is not 50 but is what? Minus of 50 with proper sign on the left side. And question says find out position of the image and also find out whether the image is real or virtual. Write down the question. Find out position of the image and also find out whether it's real or virtual. For things to be real and virtual, you just need to remember this. Front side, real. Behind, virtual. Which means if image forms on the front side, V should be negative. Negative V will give you what? Real image. If image forms on the right hand side of the origin or the pole, then right hand side you know is what? Positive. If V comes positive, that will give you what? Virtual image. For any question of concave or convex mirror, this object you can see is in front of the mirror on the real side, and therefore this object you can see is what? Real object. Now let's write down focal length. R is minus 20. Focal length is always R by 2. You don't have to add plus or minus from your side. F is what? R by 2. R is something which you have decided already. That is minus of 20 divided by 2, which gives you minus of 10. That's the focal length. Now, 1 upon F equals to 1 upon V plus 1 upon U. What is F? Minus of 10. V, we are interested in it. We don't know the position. Unknown things should be used without any sign. V as it is. Plus 1 upon U, which is minus of 50. This gives us 1 upon V as 1 upon 10 minus 1 upon 50. That is 1 upon V is coming, take LCM 50, 10, 5 minus 1, which gives us V as 50 divided by 4. V is coming what? 50 divided by 4. So this is 50 by 4. F with proper sign, V with proper sign, U with proper sign, and then we found 1 upon V. Just a silly mistake. 1 upon V is what? Minus of 1 by 10 plus 1 by 50. Make this correction. So this becomes what? Minus 5, and this becomes what? Plus 1. This becomes therefore minus of 50 by 4. Plus and minus, they are very important because they will decide whether things are real or virtual. And then later on you can figure out yourself whether this thing should have come positive or negative. I was looking at the board because I knew something that it should be a real image. How do I know that? You will also get to know later. As of now, V is coming what? Minus of 50 by 4. The moment you see negative sign is what? Real. Real what? What is V? Image position. And therefore, we got what? Real image. And this real image is forming somewhere here. That's the position of image, which is coming at 12.5 centimeter. Image. What type of image? In front of the mirror, real image. Now, Let's take another example. Suppose we have been given a convex mirror. And again, question says that radius of the convex mirror is 20 centimeter. Radius is 20. If radius is 20, you will write now R as plus 20. For the first one, we had R as what? Minus 20. This time round, R is what? Plus 20. How do I know? That's the principal axis. This is pole. Pole is origin. And center of curvature for this sphere lies on the right side of the origin. Things on the right side, they are what? Positive. And therefore R is what? Plus 20. Object is, let's say again, at a distance of 50 centimeter. If this much is 50, then it's in front of the mirror, which means U is what? Minus of 50. And we need to decide position of image and whether it's real or virtual. Let's use the formula. Formula says 1 upon F, 1 upon V plus 1 upon U. We have calculated R. That gives us F as R by 2, which is coming plus 10, plus 10. That's your focal length. Put these values in this equation. 1 upon F is coming 10. We have to calculate. U is what? Minus of 50. This is minus of 50. This gives us 1 upon V as 1 upon 10 plus 1 upon 50, which is 55, 1. That is coming 6 by 50, or your V is coming 25 by 3 centimeter. Important thing is we have found the position with sign plus. Plus means what? On the right hand side of the origin. Right hand side means what? Behind the mirror. And behind the mirror things are what? Virtual. And therefore this plus sign tells you that image is a virtual image. And it forms somewhere here. That's the position of your image at a distance of 25 by 3 centimeter. So the final conclusion is what? Things which are known, take them with proper sign. Unknown things without any sign. Regarding radius, always decide radius with the help of the center of curvature. If it falls on the right hand side, take it positive. If it falls on the left hand side, take it what? Negative. And then in front of the mirror is real, back side is what? Virtual. For any type of mirror, use this logic. Note down everything.